Okay, so let's continue with the case. So remember, in this one, NCC people were taking the on a steady approach with the NCC boundary condition, the new one. So when you use the sliding meshes, usually, or it is fully on steady. All the dynamics and everything is set here. Besides, now we're not talking about snappyHexMesh. We're talking about putting things into motion. Everything's set here. But let's move to the next case. So the cases you should have this folder CSTR1 impeller MRF simple. So now when you use MRF, usually you run uh, the state simulations. The simple approach is the one used in OpenFOAM. You can also use the unstable approach where it makes absolutely no sense, but it is exactly the same. So the difference here, it is exactly the same. But if we look at here, run all, we have everything here, but pay attention that now we don't do the steps to do the manipulation, create the NCC patches, because we don't need that. Okay, we only need to have the region. So these steps, we don't use it here in the new with the MRF. You can use that mesh, there is no problem, but it is enough to have that cell zone, okay? But you can use it. You can have the NCC, so you can run MRF steady, get a good solution, and then switch to unsteady. There is no problem. But usually MRF I run using just the cell zone that is created in the snappyHexMesh. Okay, so the dictionary is exactly the same. The only new steps to create the NCC are these. Okay, all these steps we create the NCC, and this is for sliding meshes. MRF, same steps, but we don't use the NCC. We're going to run the simulation. Okay, so nothing to add here, and you will see here that this is a super fast computation. Okay, so the mesh will be exactly the same. Then we set up the case, and the setup of the case here, and let me go back here, constant, everything now is MRF properties. Okay, so see that you need to identify the region, give the reference values, and now we get the same, okay, the same values. We use the same values as for the sliding meshes. uh, and then the other thing is boundary conditions, okay? Important, it is on the slides. So pretty much turbulence modeling is the same approach, nothing changed. So look at here that we don't have the NCC patch because I don't need it, but you can put it if you want, but it's not necessary. The only difference here, now we go into, okay, U. So the walls that are inside that cell zone that you identify here, these walls, by the way, there are a few comments there. Always I invite you to read when you see these links. That wall, you need to set this boundary condition. MRF no slips. This is a big difference. In OpenFOAM 10 and older, you need to do something like this. Okay. Now needs to be like this. So be careful about this. So also you have some comments there to know what is happening there. And what I was mentioned that the chaff is also rotating, so you give something equivalent to the chaff. Okay, but be extremely careful. You need to set up that. If I would recall, it would run, but the results will be completely wrong. Now that it's running, okay, this should be fast. We check our Y plus. So here we don't have any boundary layer, addition, inflation layer. So see that this is well resolving. If you want, try to add boundary layer, and probably I think 5 layers will be enough to have something well resolving. The simple approach will be still will be fast. When you run on a steady sliding meshes, this will be much slower because now that you have a smaller cells, your time set will be smaller and much more time consuming. So let me go here. See us. See, one impeller. Oops, one impeller. Let me put some. This Python to Python washer doc. And there you go. So we have here continuity errors, some bounded variables. And look at that already here. This is not due to the fact that we don't have the NCC. Probably with the NCC would be worse. I know, so you can do the benchmarking, but look at continuity errors are larger now. So this is the fact that we're using this MRF and so on, so some part of the physics missing. Then also it is steady. If you run a steady, probably will be smaller. So these things, small things that you can check later. Run a steady on a steady. Look at the errors, and if you use the NCC patch, what happens here and so on. But pretty much it's a smooth convergence. And later now, when we do the post processing, we're going to check. We're not going to have, by the way, the same problems as with the NCC or with the sliding in ParaView. Okay, here you don't have those problems because we're not using NCC. So clearly you see that that stuff is related to the NCC. Here you don't have anything, no NCC. It runs with no problem. So at this point, let's wait for the final solution and I'll see you later. Okay, we're back. We have a solution. Uh Perfect solution of the divergence. Okay, happy for that. Uh our monitors here, what I was mentioning, now discontinuity errors are a little bit larger. Okay, because we're running a steady, okay. So, but it shouldn't be a problem. Because we're running a steady. But if you're running a sliding meshes and you see something similar, no, this order of magnitude, that might be a problem. Or check something. Okay, but any case, by the way, also to stress, don't look at these residuals. These are not an indication of the convergence rate. This is just telling you that things are going in the right direction, but it's not telling you that the convergence is okay. For that, you should monitor another metric. But in any case, that is the subject or something else. So we have our solution, no problems at all. And let's do the post-processing in parallel using Paraphone built-in. So now remember, everything is going to work. There are no problems. So we remove those NCC patches that they are not compulsory for the MRF. We use our traditional workflow. Everything is okay here. There you go. This is our solution. So say that we reach 1,000 iterations, okay, relatively fast, and we have a quite nice feel on it. Then what you can do that you have this, use it, you can interpolate this to your sliding meshes, or you can have the same mesh and you only change the keywords to use the NCC. It's up to you, but you have the two solutions. So I think what else can I cover? No, I think you have Q criterion and everything. Yeah, nothing new to add here. So thank you for your attention. See you next video.